Hi, welcome back to the second part of chapter 4, which is the second subtopic, which is about binomial distribution. In this subtopic, our objective is the same thing, which is we want to calculate the probability of the binomial distribution. But before we go with the calculation of the probability, so first thing that we need to know is the assumption of the binomial distribution. So binomial distribution, bi stands for 2. So meaning that binomial distribution, so before we go with the calculation of binomial distribution, so we need to first to assume the situation need to fulfill the assumption of binomial distribution first. Then we can consider the situation is the binomial distribution. Then we can use the binomial distribution to calculate the probability. So let us have a look what is the assumption of binomial distribution. Okay, so the assumption of binomial distribution, there is 4 assumptions of binomial distribution. So all of these assumptions should be fulfilled, then the situation is considered as binomial distribution. If at least one assumption is not fulfilled, then the situation is not binomial distribution. Okay, so what the assumptions are? So the first assumption is only 2 outcomes, which is success and failure. Okay, so meaning that whenever we are having 2 outcomes in our situation, then the desired outcome we call it as success, and the not desired outcome we call it as failure. Okay, let me give you this example. Let's say we are tossing a coin. So when we toss a coin, we will only come up with 2 outcomes, whether we are going to have tail or whether we are going to have head. Okay, so this is means by 2 outcomes. Alright, okay, so let's say we are interested to know if we toss the coin to have the outcome is tail. So we are interested in tail. So tail, this one we call it as success. Whereas the other one, which is head, is going to be the failure. So the probability of getting tail, which is our success, so this one we call it as a probability of tail, which is P. Whereas the probability of the failure, that one we call it as Q. So you know that when we come up with the tail, because there's only 2 outcomes, so the probability of getting tail is 1/2. So means that our P is 1/2. Alright, so for getting the head, which is the failure, which is the Q, is also 1/2. So the Q also 1/2. So that is the meaning by the first assumption. Only 2 outcomes. The desired one is success, and the failure one is the non-desired one is failure. Okay, so now let us go with the second assumption. So the second assumption here, it says that fixed number of trials. Okay, so before we go with the explanation, so first you need to know what is the trial, which is trial we represent as N. Trial meaning that what is the action that we do to check on our outcome. So what things that we check on to come up with our outcome. So let's say just now, to come up with our outcome, which is the tail or the head, we need to toss the coin, right? So tossing the coin is the action to come up with the outcome. So that is our trial. So meaning that here, fixed number of trial, or M, means that we know how many of the trial that we are doing. So let's say we say that we toss the coin for 3 times. So we know how many of the trial we are doing, which is 3 times. Or we say that we toss the coin for so many times to come up with the head. So this one, we don't know how many our action, right? But we need to do the action until we come up with the head. Maybe we toss the coin for the first time, straight away we come up with the head. Or maybe we need to toss for the third time, then we can come up with the head. So we don't have the fixed trial. So if we don't have the fixed trial, or we don't know the fixed number of our action to come up with the outcome, so that is not fixed number of trial. We should know how many is it. We should know which is 5 tossing of the coin, 10 times tossing of the coin. So we need to know the fixed number of the trial. That's the meaning for the fixed number of trial. Then we go with the third assumption, which is the third assumption is independent trial from each trial. Okay, so let's say we toss the coin for 3 times. So if we toss the first coin, let's say we get head. Okay, so then we want to toss for the second time the coin. So if we get the head for the first time, it doesn't mean that for the second time also we need to get the head. We can get the head, we can also get the tail. So it not depends on the first trial, and the third trial also the same thing. If the first one we get head, if the second one we get head, the third tossing also is not necessary we are going to get head also. We can get head or we can also get tail. So it's not depends on the first trial or the second trial. It's independent for the each of trial. That's the meaning for the third assumption. And the last assumption, it says that P remains the same from trial to trial. P, as we know, P represents the probability of getting the success event, which is in our case here, success event. Just now, let's say we tossing the coin, we want to know how many we can get the head, let's say. So now, head is our desired event, our desired outcome, which is now is our success. So the P is the probability of getting the success event, which is getting the head. So we know that there are 2 outcomes. So to come up with the head, the probability is 1/2. So now we know P is 1/2 or 0.5. Okay, so let's say we toss the coin for 3 times. So if we toss the first coin, to come up with getting the head, is the probability is 0.5, 1/2. If we toss the coin for the second time, the probability of getting head also 0.5, 1/2. When we toss the coin for 3 times, also the probability of getting the head is also 0.5, which is 1/2. So that is the meaning by P remains the same from trial to trial. Alright, so that is all the assumption for the binomial distribution. Okay, so if all 4 assumptions are fulfilled, then the situation, we call it as a binomial distribution. Okay, so for binomial distribution, the notation or the model of the binomial distribution is given to us with X, which is X represents our discrete variable. Again, binomial is only for discrete variable because this one is in chapter 4. Chapter 4 is about discrete variable. Okay, so X is variable, any discrete variable that fulfill the 4 assumptions of the distribution, binomial distribution. B represents for binomially distributed. And N here is our trial, and P here is our probability of success. Okay, so if we are getting this this notation here, so we know this is binomial distribution with the N number of trials, and P is the probability of the success event. Okay, so after we know all these assumptions and the notation of binomial distribution, let us proceed to the how to calculate the probability of binomial distribution. So this is the formula for calculating the probability for binomial distribution, which is P. Again, P represents the probability. X here is our variable. equals to the small x here. Small x is the number of the data, or the value of our data. Alright, okay. So the formula to calculate is n. Again, n, which is n is our number of trial. And then we have c. C here represents the combination of the outcome. Alright, so c, later we can use calculator to come up with the c. And then we have here x. So the x here again is number of success. Alright, and then we have p. So p here again, p is probability of success. And again we have x, so to the power of x, which is number of success. And then we have q. So q here is probability of failure, and then to the power of n minus x. Alright, okay, so again this formula only apply whenever we are having the symbol here is equal. Alright, it's only applied on the symbol of equal. Other than equal, you cannot apply straight away this formula, but you need to change in terms of the equal first, then you can use this formula. Alright, so let us have a look at the example of the question, how we want to calculate the probability. Alright, so again, since that this one is discrete probability distribution, so it's binomial distribution, so to calculate the probability, whenever we are having these phrases, so these are the symbol for the probability. Alright, so if the question says that what is the probability getting the number of the head is exactly 1. So exactly, we know that we are doing for this one. So our probability is going to be x equals to 3. Sorry, x equals to 1. Let's say I'm using 3. Okay, so let's say again the question asking, when we toss a coin for 5 times, what is the probability of us getting number of tail is less than 3. So less than 3, so we know that less than is here. So means that our probability that we want to find is x less than 3. Alright, okay, so the same thing for each of the phrases that we want to find out. So we can refer to this table for the phrases. Alright, okay, so let us have a look at the example. Okay, so let's say we have this example. The number of red balls selected when 10 balls are drawn from an urn which contains 15 white and 5 red balls. Okay, so this one we know that inside of the urn, okay, let's say inside of the bag. Inside of the bag we have 15 white and we have 5 red balls. So all together the balls in the bag we have are 20. Okay, so we only select 10 balls from the bag, which is, it says that we only drawn 10 balls are drawn from the bag. Okay, so the number of red balls selected, which is now when we select 10 balls from the bag, we can have the combination of the color, which is we can have white balls, we can also get red balls. Okay, but our interested ball color is, what we want to know is we want to have the red ball. So now our success is the red ball, our failure is the white ball. Okay, so the probability of getting the red ball from the bag is 5/20, because we have all together balls are 20, red is only 5. So the probability of red, which is P, is 5/20, or 1/4, or 0.25. That is our P. So when we have P, automatically we can have Q, which is Q is the probability of failure, which is Q is 1 minus P. So 1 is 1, no issue. So 1 minus P, which is 0.25. So our Q is 0.75. So that is our Q. or the same thing, which is the probability of the white ball, which is we have 15 balls over all balls, which is 20. So 15 over 20. So we will come up with 3 over 4, or also 0.75. Okay, so that is our P and Q. And again, we know that our N is 10 ball, which is we need to take the ball and then we check the color. So checking the color will come up with our outcome, whether we get red or we get white. So how many balls we need to check? 10 balls, because we drawn from the back, which is 10 balls. So now we know our N is 10, which is this one. Alright, so now we have all the information for the binomial distribution. So then we can start calculating the probability. Alright, okay, so the first question. So the first question here. Find the probability you will get 0 red ball. So find the probability again when we want to calculate the probability. Okay, so for the first question, the question asks us to find the probability you will get 0 red balls. So again, if we want to calculate probability for the first question, probability, we always represent probability with capital P. So what probability you want to find? We want to find the probability of getting the number of the red ball, which is our variable, number of the red balls. So our variable is number of red ball. You will get 0 red ball. So when we get 0 red ball, it means that number of the 0 red ball is 0, right? So again, if we refer back to the table of the phrases just now, is here. So means that what we are looking for is x equals to 3. So we substitute this into our value just now. So x equals to 0 in our case, because get 0 red balls. So that is the first probability that we want to find. Okay, so let us calculate how this one to calculate for the probability. So again, we have N is 10. Our P is 0.25. Then our Q is 0.75. So what we want to do is, we want to calculate P x equals to 0. Okay, so we know that the formula to calculate for the binomial distribution given to us with, let us go back to the formula. So the formula given to us is this one, which is we have x equals to x. So in our question just now is x equals to 0. So when we have equal, so the formula is equal. So our question also equal. So we can straight away substitute this formula into our question. So NCX P to the power of x Q N minus x. Okay. So this one, so the formula given to us is NCX, another page. Okay, so NCX P to the power of x Q to the power of N minus x. So N is our number of trial. So we know our N is 10. So we can substitute with the value. So 10 C, then X is number of success. So number of success is whatever the probability that we want to find. So you can see that x equals to 0. So our x is 0. And then P. So P, whenever you want to substitute into the formula, for P and Q, always put bracket. So P here you have 0.25. So you have 0.25. To the power of x, again our x is 0 to the power of 0. And then Q, so we have 0.75 to the power of N minus x, which is 10 minus 0. Okay, so after we substitute, then we can calculate for the value. So we use calculator to calculate for the probability. So you just substitute the value into the calculator. For the C in your calculator, you just can press Shift and then you press the divide button. Then you will come up with C. So you substitute all the value, calculate into the calculator. So you will have 10. C is Shift divide. and then you have 0, and then you multiply, put bracket 0.25, close bracket, to the power of 0, and then again multiply. So for Q you put bracket 0.75, close bracket, to the power of 10, which is 10 minus 0 is 10, so to the power of 10. So you will have 0.056313514, take 4 decimal places. So you will have the value of probability 0.0563. So that is the probability when you draw balls from the bag. You draw 10 balls. So the number of getting no red balls at all is 0.0563. Alright, okay, so that is for the first question. Let us go back to the second question. So second question, I'm going to use the red color. Okay, so second question, again, find the probability. So for the second question, what you want to find is, again, the probability. Alright, okay. Then, find the probability, you will get no more than one red ball. So again, what we want to find here is the number of the red ball. So the number of the red ball again is our variable, which is x. And then no more than one. No more than one red ball. So let us have a look at the phrases again. What is the symbol for no more than? Okay, so no more than, we can see that no more than is here, which is no more than this one. No more than. No more than. The first phrases. The first row of the phrases, no more than. So we know that our symbol is going to be x less than or equals to 3. Or in our case, x less than or equals to 1. Okay. Alright. So again, this one, let us go to the next page for calculation. Okay, so before we go with the calculation, so again, you know that this one, it's not equal sign. It's less than or equal. It should be only equal. So if we know that less than or equal means that 1 is included. Alright, so when 1 is included, so whatever that we want to find, the probability is the probability of x equals to 0 plus with the probability of x equals to 1. Alright, because 1 is included, so 1 also will be plus here. So now we can see that both of this probability is equals to 0, equals to 1. So we need to apply the formula into both value of x. So let us go to the second page. So we know that what we are doing is probability of x equals to 0 plus with the probability of x equals to 1. So for the first one, px equals to 0, apply the formula, plus with the px equals to 1, also apply the formula. So meaning that in the first one, our x is 0. Okay, so this one, n which is 10, c x which is 0, p which is 0.25 to the power of 0, q which is 0.75 to the power of 10. So this whole thing here is for x equals to 0. And then we need to plus, and then again for the x equals to 1. So the same thing, we apply the formula. So for the x equals to 1, we will have 10. C, our x now is 1. So 10C1. And then P, 0.25 to the power of 1. And then Q, which is 0.75 to the power of 10 minus 1. So this is the x equals to 1 part. So then you can use calculator to calculate for them. Okay, so for the x equals to 0, just now we already come up with the answer because we already calculate just now x equals to 0. So we just can substitute the value 0.0563. So this one you know is 0.0563. And then we plus with the x equals to 1. So we just substitute the value of 1 into the x. So this one we will come up with, let me calculate for the value. 1. This one is 10C1, 0.25 to the power of 1, and then 0.75 to the power of 9. So we will have the value 0.1877. Take 4 decimal places. So you will have 0.1877. Alright, so we plus these two together, 0.0563 plus with 0.1877. So we will have the value which is 0.244. So this is our answer. For no more than 1 red balls are drawn. Okay, so then for the third question, so I'm going to use the green color. Okay, so find the probability you will get at least 1 red ball. Okay, so again for number 3, I'm going to write it here, number 3. Okay, so find the probability again, P of what? P of getting the red ball, which is X, at least. So again, at least 1 red ball. So at least again, if we want to refer to the table, so at least is here. So means that X greater than or equals to 3, or in our case is greater than or equals to 1, which means that greater than or equals to 1. Alright, so this one again, if you can see that the symbol here is more than or equal. So let us go to the next page. Okay, so what we have here is probability of X greater than or equals to 1. So again, if you can see that the symbol is not only equal, it more than or equal. So if you want to change this in terms of equal, so more than 1 or more than or equals to 1 means that 1 is included, and to the greater number. So meaning that what we have here is the probability of X equals to 1 plus probability of X equals to 2 plus probability of X equals to 3 plus probability of X equals to 4 plus probability of X equals to 5 plus probability of X equals to 6 plus probability of X equals to 7 plus probability of X equals to 8 plus probability of X equals to 9 plus probability of X equals to 10 until plus the probability of X equals to 10. Why only up to 10? Because we only draw 10 balls from the back. Alright. So if you want to apply each of the formula into all this equals to 1 until all equals to 10, it's a very long calculation. Yes, we can do that. We can calculate one by one, doesn't matter. But we can have the shorter calculation, which is, you know that in this ball that you drawn, if you draw 10 balls from the back, you might have 0 red ball, or you can also might get 1 red ball only, or you can also might get 2 red ball, or 3 red balls, or 4 red balls, until the 10th ball that you draw is 10 red balls. Alright, so since that what you want to know the probability is from 1 to the 10, that is the probability that you want to find. Alright, so you know that the whole probability is equals to 1. So to know for this part, so you need to minus with the probability that left just now here. Alright, so means that you need to minus with probability of X equals to 0, which means that for this case you will have P X greater than or 1 is 1 minus P probability of X equals to 0, which is 1 minus 0.0563. So you will have here 0.0563. So you will have 0.9437. That's all for the second part. See you on the third video.